Alright, hello everyone. We're doing office hours today. I got these questions out of Slack. Does anyone have any other questions we want to try to get to today? Looking at you.
Can you talk about log n and like logarithmic efficiency and algorithms and like big O?
Like log n and big O. I can try, but I actually have never used it.
Yeah, it just seems like it's something that's asked that used.
Yeah, it probably is. Yeah.
At least that.
Yeah.
Interviews that do have
We can research it together, but I don't know much about it. But I'll try to cover it.
Okay.
Anybody else? Questions? Cool. All right. I'll just go down the list. So HTML and CSS layouts. Where did he go? Oh yeah, there you go. What's up with this? What you want to know?
So, like, just I guess I wanted to do like a survey of like different layout styles, best practices, how to achieve what we're looking for really fast and in an efficient way.
Yeah, okay, so those are all very general things. We can talk about something specifically. I don't know of any like best practices that are just overall. I mean, it really all comes down to what you're trying to build. There's so many different kinds of web interfaces that we could try to build that there isn't, I wouldn't want to say like a 2-column layout's better than a 3-column layout, or you know what I mean? Like there's like a whole pile of tools, and depending on what we want to build, there are many ways to get there. Usually there's more than one way to achieve any given layout or sort of page structure. So I'd want to talk about something specific. Like I can talk about sticky footer and sticky header and stuff.
No, let's talk about that.
Sure.
That's my real question.
Okay.
Yeah.
So I'm just going to make some files here, and then I'm going to start a web server to just serve these static files. And I'll put some HTML in here. Let's call this great. And then we'll go here, and we got our sticky header and footer. Cool. Okay, so it doesn't really matter if you do like a div and give it a class of anything you want, page header. If we wanted to use like HTML5 nodes and be like a little more semantic, we could do like a nav element here. And I think there's a footer element too. HTML5 elements. There's like a bunch of new element types that were added. Yeah, there's header and footer. So we could just use those. But you could also just put a div with a class name. It really makes no major difference other than this is not going to be, this is not something that's really standardized. If some program or script was trying to parse your page, they'd have to use a human to learn about what the header was, whereas like if we use header and footer, it might make our page like more machine understandable, but that's not really important for what we're trying to do here. So I'll use header and footer here just because these are nodes that are available, but it doesn't matter. We could use a div with a class name or whatever.
I just had one quick comment on that. I was like listening to this whole podcast about like accessibility, and they were saying that like the header and footer tags are really, really useful for people who are like using like reader assist who are blind.
Sure.
Like these will call out what it is and let them know it's a header, whereas a div will just go through.
That's an example of like a machine coming in and gleaming additional information from the structure of your HTML document, which is something you would do if we were working on a site. At some point we'd say, okay, we need this thing to be as accessible to these kinds of machine readers or these kinds of disabled assist computer interfaces, right? And so we would probably come back and do like a pass through and refactor this to be like, okay, let's get one of those machines, let's get a QA person in here, and let's do some specific refactoring to make sure we're accessible to those devices. but I've never done that up front, and I'm not an expert in it, and so like I didn't know that that was true, but I knew enough to know that this means header to a computer, whereas div, class, Jared's fancy header like doesn't tell a computer anything specific, right? You can't make assumptions that way. So be aware of that, but that's not relevant to the layout that we're going to make today.
Is it main commonly used?
Main is another HTML5 element that was added recently. I mean, by recently, I mean like this century. And so these things are available, and you can read about them, and the like this whole idea of like using the correct node so that you're more semantically accurate with your HTML is like only relevant if something is parsing your HTML and it makes a difference, right? Otherwise, we could, and you can find conversations for or against this, but you could just use divs for everything, right? And just put class names on everything and style everything that way, and you would still be able to achieve the layout that you want. So we don't even need to use H1s and ULs and LIs. We could use everything could be a div and maybe a div or a span to get that inline versus block dichotomy available to us. But like, it's really just, there's a lot of play here. There's a million ways to do this. So as long as that's understood.
I think it helps with SEO optimization.
There's that too. That's another example of a computer reading your markdown, reading your HTML, and then making assumptions about it, right? So for example, Google might consider the content in an H1 to be the thing that it shows when it finds that search result. So you might want to make sure you're using an H1 tag, even though you could use a div with the style big header or something like that, right? So this is generally, in my experience, something that you'll do after the fact. Just come get your page to work the way you want it to work in browsers and phones and the devices that you're aware of, and there will often be an SEO specialist that you'll consult, or an accessibility specialist that you'll consult. And of course, you yourself could go down that specialization in your career and be like, I'm a web developer who builds interfaces that are awesome for deaf assist machines or something like that, or whatever, or blind assist machines, probably more better example. But I'm not an expert in that thing, but I've worked with folks who consulted and told me make that an H1, even though that's not the biggest text on the screen, etc. Right? Some little optimizations. But yeah.
Quick question. So like about a year ago, there was a push for this semantic web stuff.
Sure.
Is that really happening, or there was just like, there was a proposal basically?
Yeah, I mean, in some sense it's happening. But I mean, so the semantic web was like, we're going to add a bunch of different node types that mean things, so I can put stuff in my page that is more meaningful to a machine. Again, the same topic. And so I personally have not seen that go very, very far. I have not seen a huge push for everybody use these node types because it gives this additional functionality where like the web can just come, we can use an RSS reader to just read your HTML page instead of having to have RSS, right? Like none of that has happened that I've seen. So I don't think it's that important. Certainly it's not that important. What's important for you to learn first is how to take a wireframe and make it exist in the browser, and then the next stage would be make it responsive for mobile. That's going to be essential. You can't really make a successful business on the web without having those bases covered. Unfortunately, I think you can have a successful business without being fully accessible, even though we really should be fully accessible to folks who have special browsing needs, I guess might be a way to say it. All right. Let's make this. So in the header, I might just put like some sort of logo, which I'll just put like, and then we might want some sort of series of links. And so I'll make this a span, and let's get some styles in here. Let's make sure I have a link to my style sheet. And then we'll say, I almost always use a reset style sheet. In fact, I always use a reset style sheet. Does everybody know what a reset style sheet is? So in brief, and you should just read about this, every browser, essentially the short version is every browser displays HTML and that has a different HTML and CSS display default. So buttons on Firefox versus Chrome versus IE are going to be not the same width when you put the same text in them. They're going to be a little bit different. So a reset style sheet, like normalize CSS, is going to, it's a project that many people have worked on to go and make all browsers the same. Just give yourself a normalized foundation to work off of. So I'm going to come in here and do an import of this style sheet before we get going here. Okay, did that work? I can see if that worked from the network tab. And wonder if that worked. Huh, this did not seem to work the way I expected. So I'm gonna just put this over here because I know this works. And we should see, like, now see how there's less padding on this, and it's just sort of removed some of the inconsistencies across different browsers. All right, so now we want to style some of our headers. So I'm going to say the header element is background color green. So this is something I like to do when I'm creating a layout or a design, is I'll just make really contrasting colors so I can see so it's easy to see what elements are doing what or are rendered where. Cool, and then we'll put a background color on the HTML on the body, just so we can kind of see every element. One other trick I like to do, which is something I would do temporarily, is I'll do every single element with a star, and then I'll say outline 1 pixel dotted, I don't know, purple or something like that. And now you can kind of come in here and see every single element has a little bit of a dotted outline. That can help sometimes too if you're trying to figure out like where things are being rendered. Let's put some content in our footer here. And there's our footer. Great. Tough audience today. Not a single giggle. All right. So what we're trying to do is get a sticky footer and a sticky header. So the sticky header means when we scroll down on the page. So for example, this header here, if we were to scroll, oh wow, this is a sticky header. Great. So this is a sticky header. It's part of the page, but once you get to here, it sticks at the top. And then a sticky footer is a little bit different. A sticky footer would be that even though this content here doesn't take up the whole page or take up more than the page, that the footer here is at least at the bottom of the page, if not farther than the bottom, and it's never up higher than the bottom of the page. So there's a couple of ways to accomplish that too. But let's do the sticky footer first. Look at that, 5 ways to do a sticky footer. Negative margin thing is a way to do it. I'm assuming there's a Flexbox way to do it. Yep. Got it. Okay. So the way I'm going to do it is I'm going to use Flexbox. And what I'm going to do is I'm going to say that the body element, is at least minimum height. So if I had this already, but if I take this off, I'm going to give a different background color to HTML as I am to body. Did I already use orange? All right, so you can see that the HTML element has got this orange background, and the body element, we don't actually see that pink background. And that's because the body by default only takes up as much height as it needs, right? The body element, you can see as I hover here, is only this high, right? So in order for us to make it possible for a child of the body to be at the bottom of what I call the viewport, right, the viewable portion of the window, we need to make sure that the body has a minimum height of the whole page. So 100 view heights is, a view height is a percentage unit of the viewport, right? So 10 VH is 10% of the viewable height of the viewport. So that size shrinks as this shrinks and grows as this grows, right? A percentage of the view height. And so now we can get pink all the way. You can see if I move really fast, you'll see orange there a little bit. There's a little bit of a delay. But now the body is the full height, at minimum the full height, but it can grow beyond that. So that part's an important first step on this sticky footer. And then what we'll do is we're going to say that it's display flex direction row, because if we consider the body to be a row, then all of its children will be columns. So I have it backwards. We want this column because we want each one of the children here to be a row. And so we don't get anything different now. But what we can do is say that the main portion has a flex grow and a flex shrink of 1. And so what that's saying is grow to take up whatever remaining space there is. So the footer will take whatever space it needs, the header will take what space it needs, and the body will grow. Not the body, the main element will grow to the size that is remaining. So it's important that we come in here and say for both the header and the footer that these are going to be flex, grow, and shrink 0, so that we tell them not to shrink or grow, that they should just stay whatever size they need to be. So if I put a little padding on the header and the footer, we'll see that the yellow content just takes what's remaining. And that footer now stays at the bottom. So the other important side of this is if we have a lot of content. So I'll just put some duplicated P tags in here. And now we have a lot of content on our page, and the footer is just sort of normally at the bottom. So that is a pretty good implementation of sticky footer. This is actually a really nice implementation compared to what we used to have to do before Flexbox had support over all the browsers that we normally would care about. So we actually had to do some tricky stuff with, like, the footer is floating on top of the main element, and then the element has a bunch of padding at the bottom or a bunch of margin at the bottom, so it kind of tricks this. It's a bunch of really hacky, tricky stuff we had to do. You'll see that if you look at an article like this. This is looks like a really good one, 5 ways to do sticky footer. You might want to go through, if you're really into getting super good at HTML layouts, you might want to go through and just implement all 5 of these and see how they're accomplishing the same thing with totally different approaches. Cool. So that's our sticky footer. Let's give the main thing some padding here as well. And now we have, minus all these gross colors, a reasonable scroll down. And then if we just go into the elements panel here and we just start deleting some of these P tags, you'll see that the footer never gets higher than the bottom. So questions about sticky footer? Yeah, you're not going to learn to be awesome at HTML and CSS by watching other people do it. I have been doing HTML and CSS for at least 15 years, and I still feel like there's a lot of like playing around with different approaches and seeing what you can get to work and feeling out how one approach impacts some other part of the page and making sure that your CSS is actually only affecting the elements that you care about and it's not having some external unwanted effect on some other elements. There's just a ton of like unintuitive things to learn, and I think it's just drilling. I think how I've gotten good at this is just by building a lot of interfaces and solving a lot of problems and like honestly a lot of banging your head on the desk. It's pretty tricky and unintuitive, and there's a lot of really wonky weird things to know about it. So like I'm happy to show you how to do a sticky footer, but like you're not really going to be able to knock them out if you haven't built it a few times yourself.
One good thing for visualizing is a pesticide for Chrome.
Is what?
Pesticide for Chrome.
I don't know what that is. What's pesticide?
It essentially encapsulates all your divs in like a box where like if you hover over it, it like pulls it out to the front so you can see like what's actually affecting what.
That's interesting.
Which elements are.
Huh, cool. I mean, the tool, so that sounds cool. I'll check out that tool, but there's also the just straight up developer tools, which is fairly good, right? If I want to know where the what's the header object, it'll tell me, you know, up here, the top left, like what size. And I wonder if we need to focus this. It's kind of does it look blurry to y'all? And then you can come in here and you can look at like the computed styles of this thing. So if I want to, you know, if I need to know like what's up with the footer, I can come in here and I can find the footer, and it does put like a little bit of an overlay, and it tells you like this part's margin or padding rather, and then that the purple part there is the content, and that's why that's height is there, and it tells you sort of the dimensions as the rendering as a result of the computed styles. So it's like fairly decent tool here. I really like the Chrome developer tools. You can stick them on like the left and the right and stuff. Cool. So if there are no more questions about sticky footer, I'll just do the sticky header. Sticky header is a little bit trickier. I'm going to bring back all my p tags. And so the sticky header has this element where you're scrolling down and something changes depending on where you're scrolling on the page. So to illustrate that, I'm going to put another element up here. I'm just going to call this, I don't know, pre-header or something like that, because I want to illustrate the, like, see how W3 Schools has that like logo above it and then it moves, so there's like a point in the page. Well, actually, let's do one first where the header is just kind of always at the top. One easy way to do this, if we just want the header to always be at the top, is we could just say that the main element has a margin top of, I don't know, let's say 100 pixels, and then we're going to say that the header has a height of 100 pixels, but its position absolute, top 0, left 0, right 0. And so now 100 pixels is a bit high. Let's change this. These numbers need to be in sync for this approach. Let's go with, I don't know, 60 pixels. That's even a little too high. 30 pixels. Great. So now, what? Haha, I think so.
You want your position fixed, don't you?
I do want it fixed. Thank you. Fixed. Cool. So now the header is actually not affecting the page content at all. I might actually change this to be padding top. So we might need to make this a little bit bigger. Margin works for us. So if I delete the header, you'll see that there's actually just the main content is here, and then it has a margin top of 30 pixels, so it's just sort of pushed down. And then this element, oops, this logo element here, or the header element here, which I'll take the padding off just for simplicity, is that same height. So it looks like it's pushing it down, but it's actually hovering on top of it. So it's actually just always hovering. So that's one way to get a sticky header, is like it's just sort of always hovering up there, and when we scroll, it just stays there. And the reason why this content is pushed down is not because of the presence of the header, it's because we just put another separate margin top to push it down. So now we can have our nav bar just sort of always stick at the top. But if we wanted to accomplish something a little bit more complex like this, where it scrolls with the page until you get to a certain point and then it sticks, that's going to take a little bit of JavaScript. So let's talk about that. So I'm going to put this back. To what we had before. And we can, it's fixed, or static rather, inside the page. And so what we're gonna do, and this is where I need that like pre-header bit. And so now what we want is we want it to scroll with the page, and I'll give this a little more space. So we want, like, as I scroll, once I get to here, that it locks and is fixed and stays at the top. So this is going to require some JavaScript, so I'm going to get my script. And let's, we need to get document ready, which I should just learn to type. That's the guy. So we are going to bind to the DOM content loaded event. Does everybody know what this event does? Who does not know what this event does? Yay, there we go. Just like there's always a better way to ask that question. So without going into too much detail, when you put a script tag here, the script executes here. And when it executes here, that means that this content has not been processed by the browser yet. The browser processes HTML documents sort of top to bottom. And so this script starts executing before we even have a body tag or have a div inside of it or a header or a main. So if I were to try to use something like document.query selector for the header element, this doesn't exist yet. So what we need to do is say, wait for the DOM content to be loaded so that we've processed that whole document. Then these elements are available. So we can get access to our header object, and I'll show that by saying DOM ready, here's the header object. And so when we reload the page here, we're going to see that I have DOM ready, and I have this header object here, and you can see when I hover over it, it highlights that same element. So I can now start programming some JavaScript to make this sticky footer happen. So what do we need to do here? We need to say that when the document has scrolled to this position or beyond, that the header element is fixed at the top of the page. And then when we go back and we scroll before that part, that the header becomes static again. So let's work on that part first. We're going to work on making the header be available as both a static in the page element and a position fixed element. So I'm going to give another class. I'm going to give a class name here, or come up with a class name here called header fixed. And I intend for this to be added to the header element when I want it to be fixed and removed when I don't. So I'll just say position fixed, top 0, left 0, right 0. And so let's just test that manually. Let's go in here and find the header and add class header fixed. And now it's stuck at the top of the page for us there. Yeah? And if we take that class off, it's now static in the document. So that's how we're gonna do this. Is we're not gonna put any CSS in our JavaScript. We're just gonna toggle whether or not header has that class, and we can just do that by saying class list.add header fixed or remove header fixed. Okay. So now we need to know when to do that, and that's going to be based on the scroll position of the document, of the page. So we're going to bind to another event. I think on the document, it might be on the window, but we're going to get a scroll event, and we're just going to console log that event. Cool. And you can see as I scroll, we're getting a ton of events. Just scrolling a little bit, we get a ton of events, right? So there's a pretty high frequency trigger to this as you scroll. And inside of each one of these events is, actually we don't even need anything inside that event. We just need to know the document body scroll top. So if I'm scrolled at the very top of the page, the scroll top of the body should be 0. If I scroll down a little bit, it's going to be a bigger number. So as I scroll down, this is where you read that value. The scroll top property on the element that is the scrolling element. And so what we can do is we can find out what's the scroll position, like how far down is the nav bar from the top of the page. And then we can say if our scroll top ever gets bigger than that, that means we've scrolled beyond the top of the navbar element. Does that make sense? So let's log the document body scroll top instead of this event. And we can see that as we scroll down, our scroll top is increasing, and it looks like the number we're after is something like 50 pixels, right? Something like 49 or 50 pixels is right when we want to switch to fix, right? So we don't want to hard code that. We want to detect what that number is. So I think we can detect that by getting our header element here. And so when you're in the Elements tab here and you select an element, just highlight it. If you go over to the console, you can get at that element by $0. That's a nice console or Chrome developer trick. So I've got my header element, and I think I can say, what is your offset top? We get 50. So elements know how offset from the top of their parent positioned element they are. And so this header will tell us I'm 50 pixels from the top of the parent, my closest parent that scrolls. So we can use this number, offset top, to say, let's see, what's our scroll border equals the header offset top. So we know our scroll border, we don't need this anymore, and we know when this switches from, we know when we can detect whenever we cross that border, right? So we want to know every time we scroll, have we gone from either being above, have we gone from being above to below or from below to above this number? So we know this number and we know where the border is, but we need to know when we cross that, when we cross that border. So what I'm going to do is I'm going to store our last scroll top. But before that, I'm going to say, actually, we don't need the last scroll top. We just need to know whether we're like above or below. So let's say above header equals true, because the page, well, let's derive that. If the scroll top is less than the scroll border. So that's our starting state. We're above, our scroll position is above the header if the document body scroll top is less than the scroll border. Are you waiting to say that, Bonnie?
I was.
Yeah.
You deprived me of my chance to be a hero.
Haha. Cool. So that's how we know whether we're above the header. So let's log that. And we should get like a true or a false. And then we want to say two conditions here. If we're above the header or if according to this variable, the last time this ran, we were above the header, and now we are below or equal to the scroll border, then we're going to swap this thing. And then we also need to do this thing where we add header fixed to the header. And then else, if we were previously not above the header and now we are, we're going to remove header fixed from the header. So I'll put, before we start messing with this class name, I'm just going to console log just moved below header, or rather just scrolled beyond the header, and then just scrolled, I don't know, before header.
And Jared, you're gonna want to,
Yeah.
I'm
on it.
Constantly being thwarted.
You're like, I found one. I found a bug. Cool. So let's stop and just let's see if did I lose anybody with this logic here? Does anybody want to ask questions about it, or let's do this? 0 to 5 fingers. 5 being you fully understand this code. 0, you have no idea what I'm even talking about. Could everyone show me where they feel like they're at? 0 to 5. What? 5 in it? Not even paying attention. I love it. All right, cool. So anyone who is below a 3, let's try to ask a question here. See if you can help me understand what needs to be made more clear here.
I do understand what you're doing, but just a specific implementation of, like, I've never used the things that you're using. So I do get the high level idea of what you're doing, but just the specifics.
Okay.
It's something that I've never done before.
Okay. Well, let's see if my code's even good, and then I'll try to re-explain it, and maybe that'll prompt a question. So what I'm expecting is, as I scroll here, I don't want that. So as I scroll, if I'm scrolling sort of above the header, nothing happens. But as soon as I cross this barrier, I've scrolled beyond the header. And then if I go back, I've scrolled before the header. And so every time you cross this barrier, then my logic is aware of that crossing of that border, and I'm able to do some change. So the way I'm accomplishing this is I first figure out how many pixels down from the top of the page the header is, and that's my border. That's my barrier. And then I listen to I react to every single scroll. So every time the user scrolls, which is multiple times during a scroll, it's like every few pixels they scroll, I look and I see, where was I before this scroll happened and where am I now? And if those two things are different, if I was above the header before and I'm now below the header, then I'm going to say now I'm above the header false, and I'm going to log that we crossed the border. And vice versa, if I wasn't above the header before and now I am, that means I did just now cross. So does that clarify each step here?
Yeah.
Okay. So then if this looks like it works, so I'll take my logs out and I'll flop my header fixed class and we'll see what we get. And I think I foresee a page jump here. Yeah. But we do get the sticky footer. But you see that there's like the main content would be here thing that kind of jumps under, right? Do you see that? And so does anyone have a guess as to why that's happening?
If it's taking that out of the page.
That's absolutely right. Yeah. So let me illustrate that by saying whenever we go header fixed, we're actually just going to display none. We're just going to hide that thing. So notice that main content is some number of pixels below this pink content, which I should have actually given that its own color. But as we scroll, it gets taken out of the DOM And so now, oh yeah, I'm actually not able to, okay. It's actually taken out of the DOM, and so the yellow content actually goes up a little bit, right? Does that make sense? So I think in order to fix that, we are going to need to we're going to need to do something where this element that's in the page here, because if we swap this by adding that class header fixed here, we actually take this element sort of out of the flow of the document, right? It no longer takes up space, and we need something to continue taking up space. Does that make sense? So in order to do that, there's a bunch of different ways we could do it, but I think what I'm going to do is I'm just going to put, I'm going to wrap everything in a div here. And so now I'm going to actually leave this header element in place here, and I'm only going to position fix this part. So we'll still have an element that stays in the flow of the document and takes up space, but this thing will now float above that. And so in order to do that, there's a couple ways we could do this, but I'm going to just fix the height of the header to being like, I don't know, 60 pixels high. And I'm also going to say the header content is also 60 pixels high. 60 is a lot. Let's do 30. Great. And so now what I have in my DOM here is I've got the header element, and I'm actually going to move all of this stuff into the content. Oh, I still need this. So now I've essentially just pushed everything that was in my header. Oh, I know why that's happening. It's because of the padding. What's that thing called? What's that thing? I can't remember, but because we've got this now 10 pixels of padding, I need to make this 50 pixels high, right? Because it needs to account for that padding. Okay, so it's a little hard with this green, but I'll try to zoom in here. So you can see the header here is this full green box here. And then the div inside of it is the exact same height. And it's getting that by having a height of 30 pixels and a padding of 10. And there's a top and a bottom padding, so 30 plus 10 plus 10 is 50, right? So that's why the header's 50 pixels high, so that this div can be the same height on the inside. This gets a little wonky having these two different heights that have to be in sync. There's some better techniques, but they get more complex, and it's not really relevant to the sticky part of this, so I won't dive too much more into it, but we just have these two elements now. And the idea is that the header, if I display none this thing, the header is still there, and it's taking up that 50 pixels. So even if I move this content, it doesn't push that yellow content down. It doesn't push the main content down. And that's what we're looking for. So then we need to change header fixed to actually not change the header, but to change the header content. So an element that has header fixed, so when I add header fixed to the header content's going to be position fixed. And now we no longer get that jump, and it's nice and smooth. There we go. Sticky nav bar, sticky header. Cool. So there's again a number of walkthroughs and guides on how to implement this stuff, and there's a bunch of different ways to do it. And there's some tricky things like having to make sure that the place where you take the nav bar out of or the header out of doesn't go away, so the content doesn't move, and some other things like that. So, but that's an example of doing sticky nav bar and sticky footer. Any other questions about that? That took most of our time, unfortunately. Now let's talk about this arrow function versus normal function. Yeah, who was asking about that? Okay, cool. So let's see. So JavaScript didn't used to have arrow functions like, so here I'll just use 2 examples or several examples of the same thing. So JavaScript used to only have these 2 ways of defining a function. And so you used to only have these first 2 ways. There's some differences between these 2 top ways here that has to do with hoisting. The short version is this gets defined sort of before the file even executes. It gets sort of hoisted to the top of the file, and this does not. So there's some trade-offs there. I think you should just kind of always use this one. I find it's mostly confusing and rarely useful to use that one. That's a personal opinion, but certainly isn't shared by everyone on the internet. But if you just always do this one, I think you won't get surprised by the way that your code executes. But then we added recently these 2 new ways of defining functions. Called arrow functions. Probably the main motivation here was that everybody just hates writing the word function. It's a long word and you typo it all the time, and there's just like no way to have like concise code that looks lean and terse with the word function 50 times in your file, right? So this is effectively equivalent to this, although there's one major difference which has to do with the value of this, but I'll cover that in a second. I want to cover the difference between these 2 things. These are essentially the exact same function. One is using explicit return and one is using implicit return. And so you are allowed to take a function that has a single expression. You only have one thing that you're doing. You're not doing more than one line of code or expression of code. You can take that, and if you remove the curly braces, it will then implicitly return whatever the value of that expression is. And the appropriate place for that would be inside of like a one-liner like this, where we were doing like map n to n plus 10, right? So this is a simple function here that takes one parameter and just returns a modified version of that parameter using a single expression. If we needed to do something like if n is greater than 10, do this, then we would not want to use an implicit return function that didn't have curly braces. If this needed to get more complex, we could just wrap curly braces around it and put a return, and that would work the same. So that's how implicit and explicit return work. This is the only form of implicit return in JavaScript. Every single function must have a return statement unless you want to return undefined, in which case that's the default return. If you need to return something, you need to put the word return, except in this case here. And I would, again, avoid using implicit return and lack of curly braces unless your function really is this simple. Really is something this simple. Cool. So that's the difference between these 2 things here. And now a major difference between the function and the arrow function is how the value of this works and what the value of this will be. How many people here think they have a decent understanding of how the keyword this works in JavaScript and know how to set it and know how to tell the computer what this should be when you execute a function? Okay, well, without going into that, which could be a whole lecture on its own, the value of this when you run a function changes depending on how you run the function for these functions. You can decide what the value of this is for these functions, and there's a bunch of different ways for you to tell the computer what you want that to be. However, these functions, when you use an arrow function, the value of this is whatever the value of this was when you defined the function. It's effectively automatically bound to whatever the value of this was when you defined the function. And so if most of you don't fully understand like what the variable this is and why it's used and how to change what its value is, then it may not be clear why you would want this new feature of a function that automatically inherits the value of this. You won't fully understand that, but I'll try to give you a couple of examples that maybe will give you an idea of how that works, and then as you master this, you'll come back and understand why this was a useful addition to the language.
Does that mean it's impossible to create a constructor function using an arrow?
You cannot use an arrow function as a constructor. Correct. That's another difference. Thank you. I wasn't going to say that because I didn't come to me, but that's true. So if you know about constructors, you can't use an arrow function. I believe it even gives you a full real error if you just say like, here's an arrow function and then new x says x is not a x is not a constructor. So there's another difference there. So if I try to give you an example, let's say we have, I don't know, if we just have like a frog whose name is Laura, and we have a speak function. And this just takes a message and console logs the message. And then we have another function, we have another thing down here called, I don't know, favorite. I don't know. How am I going to do this? So when you have functions defined on an object like this, if I call frog dot say your favorite colors, inside of this function, when it runs, this will be the frog object. And so we can say things like this dot favorite colors dot for each Okay, so when I say this, say your favorite colors, we call that function, and this function has access to the frog object through the this variable. So it knows this dot favorite colors, or rather this dot favorite colors is a way to access this property on this object. So we can say, go get this property, get this array, and for each element in that array, call the speak function, which is also on the frog object. So let's dig into this. Is this let's make sure we get clarification about how this is working. Does anyone have questions about this code?
Yeah.
Yeah.
Could you also not write this and it will still do the same thing?
This would not work. Sorry, writing code in the, you can't avoid that word. You just can't. The code I have highlighted, if you were to remove it, would not work.
Okay.
Because this is not a local variable to this function, and it's also not a variable that was inherited from a super scope, from a previous scope, right? This is a variable reference. The code I have highlighted here is is a reference to the frog object, and then the code here is a property of that object.
Okay.
Yeah?
Yeah.
So yeah, what I always understood before is if you're not inside of an object and you just have functions, this is referring to the window, right?
So now we're getting into how do we call functions and declare what the value of this should be. And there's a bunch of different ways to do that, but all I'll say on that is by saying frog dot this function, we are saying when you run this function, the value of this should be frog. So that there's more to it there's more to this than that. Yeah. But here is why. When I call this function, the value of this, when it's executed, is this object. Okay? So, but the code I have here actually will not work. And we'll see why. this dot speak is not a function. Okay. This dot speak. When I wrote the code here, the word this here, I expected it to also reference the frog object. But let's find out what happens. Let's do a little introspection, a little debugging. What is this here, and what is this here? And I'll just say this A and this B, okay? So this A was the object I expected. It was the frog object. But then when I got inside that for loop, it became the window object, right? And that's because I'm using this original function. I almost said old school, but it's not being replaced. That's an important part about these distinctions here. The function and the arrow function. The arrow function, if you're thinking of it as like the new version, the new better function, it's not. It's a different function for different reasons, for different cases. And so this is one of those cases. When I'm using the older function, what we used to have to do in JavaScript was that because of the side effect of defining a function this way, one of the side effects is that the value of this is no longer locked to the same value of this here. So what we used to have to do is something like we'd say var that equals this, and then down inside of this function we'd be able to say that, or maybe we'd call this frog, or maybe we'd call this, you know, whatever. The variable name's irrelevant. But what we're doing is storing a reference to this special keyword. This isn't a variable, keep in mind. This is a special keyword for the execution of this function. But it refers to an object. It has a value. So we put that value in a variable, and then this function can lexically inherit, using lexical scope inheritance, can inherit that variable, and now we have a reference to what this was at the time down in this lower function. Yes?
So if you change that function down there to be an arrow function, will this still be bound to this in the same way?
You're giving it away. You're giving my whole, you blew it. No, I'm kidding. It's exactly where I'm going. That's exactly where I'm going. So I just want to illustrate that this would, the approach
so
I have
now
on
you
the
know
screen.
How it feels, Jared.
Yeah, exactly. Yeah. So if I run this, oh, I got to reload the page. If I run this now, you'll see that, oh, well, let's get rid of these unnecessary logs. You'll see that it actually does pass each color to the speak function, which console logs red, green, blue. So we've achieved, this is what we used to have to do, and this is why the arrow, one of the reasons why the arrow function was added, was because this was really annoying, having to constantly keep a copy of this so that functions you define in your function can also have access to whatever this is at the time.
I've also seen people do stuff like bind the function.
Oh, sure, yeah, okay, I'll show you that. Great. So another way we could do this is we could when we define this function here, we could actually define a new version of the function that is bound to this so that the this, when that function executes, is our this, right? So that's another way, and I'll show you that that works. Okay? Yes?
In that case, how does it know that it should be binding it to, because there's those three different methods. There's like bind, there's call.
Nah, irrelevant. Call and apply would not solve this problem here.
Okay. So you're binding it, and how does it know that that's the this it should be?
I told it.
You said this.
I could have bound it
because
to.
it's inside of frog, it knows that.
No. I gave it the object. I said bind to this thing. I could have bound it to an array of 1, 2, 3 if I wanted to.
But how is this in that case the object?
I think you might be misreading this.
Well,
So,
you're binding it to.
well, yeah. But let me clarify, because I think I understand. I think I understand what you're saying. So sorry if I'm wrong. This function here, okay, that's being executed from line 35. So line 35 takes this function and it calls it. The first thing that function does is it says this, which gives the frog object, and then it says dot favorite colors, and then it says for each. And before calling for each, this code happens. So I'll break this out. Const x equals this function bound to this, and then we give it to for
because it's
each.
hoisted.
No
Because-
hoisting is happening.
But isn't that the reason that like you pulled it out like that? Because when it's an
No,
old school function,
I just pulled it out so it was easier to see that when the computer executes this line of code here, these 3 lines of code, it does this highlighted part first before calling for each. So it first creates an anonymous function, then binds that function to this, then passes that bound function to for each. For each will then internally call that function, which was already bound to what this was at the time. This and this are the same sort of, this, and this are for this function, and this is for this function. Does that make sense?
I think it does. I mean, it makes sense. So I guess that when a function like for each is executed first, the things inside of it have to be.
There's nothing inside of for each. There is an argument being created and that is being passed to for each. So before for each executes, we must create this argument. So for example, a simpler example, console log 10 plus 5. We must do 10 plus 5 before we can get the value that is the first argument passed to log. It's the same thing that's happening here. We must create this function and bind it before we can give it to for each.
Okay, and when it's bound, when that happens, when an argument is inside of something like for each, like that, it's kind of like 10 plus 5. It's that is happening outside of or in the scope of.
Yeah, that's why you shouldn't. That's why using the phrase inside of for each is a misnomer. It's not. I wouldn't
It's outside
describe
of
it
the
that.
scope of for each, or it's
Yeah,
in the same
for
scope
each-
as fraud.
For each has no knowledge of this code here and how it's executed. It only knows the return value. So that's why if I take this code and I just take the return value and I store it in a variable, that's the same thing. Because for each knows nothing about this code. It just knows it was given the result of that code. So when I put this code in here, right, maybe formatting it like this might be helpful, right? This has a return value, which becomes the first and only argument that I give to for each. Just like down here. This has to happen first before log. Log doesn't get 10 and 5, it gets 15. It has no idea that 15 was a derived value from 10 plus 5.
So I guess I didn't know that. The parameters have the scope, which is immediately outside of the function that's calling it. Does that make sense? Like the
What-
parameters that are inside of a function have a different scope than that function that's calling it. Can I say something?
I'm not, well, I don't know because yeah, in a second. In this case, what is calling what?
In that case,
Yeah, so like here on line 38, we're calling this function. So this function here is being executed. Then what other functions are calling or being called?
for each is within there.
For each is being called,
Yeah.
and it is being given a function.
Yeah, be given a function, and then that thing of that function then has to do its thing before its return values.
No, this function is, yeah, sorry. I understand. Yeah, saying return value might have been confusing because it's not the return value of executing this function. It's the return value of this expression, right? This expression's return value is, so this expression's return value is the function. This is also a different version of the function. X is a function. So this code here, its job when executed results in a function. And then we are giving that function to for each by passing it that function. So I can take this code and I can just put it here. And what's happening is we define a function, we then bind it, which creates a new function, and then we take that new function and we pass it as the first and only argument to for each.
Okay, so this is only when you bind something, like when you
The reason, like, when
No,
you
it's
treat
the
that
same when I do this, right? We're creating a function. This code here defines a function that is now an object. It's a value. It's a function typed value, and that's the argument that we pass to for each. And then for each takes that function and it says, and it calls it, in this case, 3 times.
Can I give another example?
Sure.
So let's say you read a file and you have a buffer.
Yeah.
This console log right after you read it, it's going to just print out the buffer.
Sure.
But if you hit toString after it, before it's actually pushing the buffer into console log, it's doing a conversion of it. It's affecting that buffer.
Right.
Console log.
Right.
So the same thing's happening here. We have this
Yeah.
function, and before we actually push this function we define into the for each to tell it what to do.
Yeah, we can do all
also
kinds of
bind
complicated.
this to it. So before the function's actually getting pushed into the for each before it's reading the function, it's already looking at the function. This in there has been changed in some way. It's no longer just this view ran of this. But this that's in there is looking at the upper disk area. Remember we set that equal to this.
Yeah, it's
So
like
we're
doing the same
passing
thing.
that reference to return this into the function before we actually hand that function over to the page. Just like before we hand that buffer over to the console.
Yeah, just like we have to do all of this work before we can give its result to console log.
So instead of this going, I don't know what this is, I'm going to use my this. It goes, oh, this has been defined as this other variable. Like we would have if we change this into that.
Yeah.
So that by the time for each is getting now what are my instructions, the this that's in that for each is no longer that function's this, it's the this one outside. Because you found it.
Right?
You modify the function for you.
So this is an order of operations thing, right? On this line of code, what happens first? Which step do we do first?
So I would imagine that, like, the parentheses inside of round, maybe.
So the very first thing, right? So let's just do it as humans, right? If we were to come up with what's the rounded value of 10 plus 5 divided by 100, we would have to first do a mathematical order of operations, right? So 10 plus 5, then divide by 100, then round it. Then we get our answer, right? We can't round first. We can't divide by 100 first, right? So we have to do things in order. And the computer has its own order of operations for non-mathematical things. So in order for us to call for each, we must figure out what the heck this is. So we have to do that part first.
Okay, and that happens in, like, I guess that's interesting. So that happens within Frog, like that. But when you
Within the
it happens
function,
outside, it must happen outside of the function.
no, it
must happen
happens.
outside
It
of
happens
the
when we execute the highlighted function that I've just highlighted.
Yeah, but like it must be like in order for the dot bind this to like it made a lot of sense to me when you said that bar that equals this, and then bar that was within the scope or was within the object Frog. So of course this is going to be.
Can you do
Referring to
this?
Frog.
Can you declare that and bind to that?
Of course, yes, of course. We could also do const. I don't know.
So real quick,
Yeah.
when you defined that, it wasn't in Frog. It was in
Nothing is in nothing is
Yeah.
in Frog
Frog
in an
is just-
execution sense.
Frog
You
is
can't
just
execute
this
Frog,
variable.
but you can execute this function here. So when we execute this function, right? So let me walk you through
Okay,
the
so
order.
inside that function.
Right, so when this function is called, which is happening here, the very first thing that happens is we declare this function. We don't call it, we don't execute it, we just make it. It's not even in a variable, it's just a thing. And then we create a new version of that function that is bound to this. Okay, so then so step 2, we have declared a function and then we've created a new version of that function bound to this, to whatever this is for this function. And then once we have that function that we just created, we give it to for each. And it calls that function 3 times. Okay, so because you had asked me to, that equals this. We could also just use that here, because it's the same thing. They both resolve to the same Frog object, right? We could use that here, and then we wouldn't need to do the bind, right? It's all just trickery to get access to the Frog object. Okay, and I gotta wrap this up. So where I'm going here is that all those tricks go away if you use an arrow function, because arrow functions by default automatically inherit the value of this from the scope that they were defined. So by just declaring an arrow function, you're also implicitly declaring what that arrow function's this value will always be. If you did a dot bind, it wouldn't do anything. You cannot change the value of this for an arrow function. So we use arrow functions in cases like this to make our code a little simpler, so we don't have to mess around with currying around the value of this at the time. So just to show you that I know what I'm talking about, it works. Yes?
I know at the end, not to throw another wrench there, but if you use strict, how does that affect this? Or is that to get around it?
Yeah, there is something else about use strict where, remember how you had said, like, if a function, sometimes the value of this is like the window object, right? So we really should just get into this in a whole lecture, and we'll do that. But if you use strict, it changes the default value of function. By default, if a function isn't told what its this value is by calling it in a specific way, if you call it on its own, this is just the global object, which is like a terrible default. So use strict changes that default to where this, if you don't specify it by calling it in a specific way, it's just null, which is much better. Okay, that's all the time we got. Thanks, everybody.
Thank you.